This is Frank. I'm just going to set up, this is a new Mac Studio, so 128 gigs of RAM. So I'm just going to kind of get started here with basics of installation that I do on a new machine. So first things first, I'm going to pull up the terminal. And actually, I got a lot of stuff to drag out of the dock here because I tend to take out this kind of thing. The terminal is definitely going in the dock. Start pulling all these other things out here. Okay, so first things first, let's go get some package management tools here. So brew.sh, and what we're going to do is use their sketchy installation mechanism here, and it's probably going to tell me that I need some tools installed first. Okay, it's actually going to do it for me, so that's cool. Um, and as soon as that's done, we'll install Rectangle so I can actually tile some screens here. So this is actually an 8K display. I'm running it HD here, 1080p, just so that it's easy to view on YouTube, I guess, if you don't have an insane screen. So let's do a couple of things here. Let's pull up the activity monitor. Let's go get menu meters. So menu meters is a great little piece. And what it does is it just gives you status up in the menu bar. Yeah, off the top of my head, I don't know. Okay, so let's get to put it in applications. Fair enough. All right, so we're going to take. Oh, so you can see here actually it's pulled all my iCloud stuff already. So that's kind of neat, although maybe a little bit superfluous in some ways. Okay, so we're going to go to downloads and we're going to move this to applications. I'm going to fire up menu meters. Couple O will open that for you. Automatic check. Okay, so obviously this is a little much here. So for CPU, we're going to do a graph, and we're not going to show the CPU temperature. And we show the average of all cores. There we go. Okay. And then for disk, I typically don't do disk activity. I typically just do disk, or no, I don't do disk IO typically. Okay, so this is usually a usage history graph. I'm sorry, I usually do a bar chart for this. Yeah, or a pie chart, excuse me. And then network, we usually do a graph and throughput. There we go. And then you can kind of get an idea of how healthy is the machine here, up here in this menu bar here. Okay, so that's a start. So hopefully we've got Homebrew now. So get this cranking here. If I open a new tab, I have Brew. Excellent. So Brew install actually the Homebrew Microsoft Edge. Microsoft Edge. Okay. What else do I want? I want a llama, and I want rectangle as a starting point. And while that's going, I'm going to go grab Oh My Zeesh. Which again uses one of these sketchy Star Lincoln and trust us situations. Although at some degree, I guess most software is like that. Okay, so now we've got terminal set up correctly. Okay, so I'm noticing I have caps lock here instead of control. So let's fix our keyboard mapping. So keyboard shortcuts. No, that's not what I want. Although there is one keyboard shortcut I like to alter, which is for screenshots. Here somewhere. There we go. Screenshots. So what I will do is copy picture of the screen to the keyboard. I'm sorry, it's not that one. It's copy picture of selected area of the clipboard. I make that just like it is on Windows Shift Apple S. Okay. So what I want to do, it's under setup keyboard. Maybe not. What I want to do is change the modifier settings. I don't think it's under here. Oh, there it is. Modifier keys under the modifier keys. Okay, so caps lock is control. All right, so that fixes that. And then the other thing I really don't like is the scroll direction. Scroll. Let's see. Use trackpad for scrolling. It should be in there. And trackpad. Scroll and zoom. Don't want natural scrolling. I prefer the old style. Okay, that's much better. Okay, so I think we're getting close to being ready here. So edge. Okay, so we've got edge now. That's good. We've got rectangle. Oops, see that? Please open edge. Please open rectangle. And yeah, so with rectangle, it needs, I believe, disability. Yeah, it needs some accessibility settings, so you got to give it that. Okay, we're going to do recommended, and we're going to disable in macOS. Okay, and that lets us do this. So I can use keystrokes to move things around. Okay, I haven't played with the macOS native stuff. I'm just kind of used to the old school here. So yeah, I'm going to set Edge as the default browser. I already have an account. Okay, that brings to mind. And the next thing we want to do is just do install 1Password and Signal. Nice speedy internet connection here, so no problems there. And then while I'm thinking about it, I'm going to go ahead and add a login item here, which is rectangle. Okay, that way that'll start my sign in. Okay, password. Well, that's another thing I meant to turn on is keyboard navigation here. Okay, and that way you can hit tab to kind of get around things. So we're going to sign in, and as me, and then okay, so I guess it already knows about most of my settings here, so just need password here. Okay, cool. So we're going to do that, and we're going to go install in the browser here. Settings. Okay, a couple of things we're going to turn on is, yeah, I don't necessarily need that. I do want the SSH keys, key fingerprints. Okay, yeah, I think that'll work. Browser, get one password for your browser. Okay, so that's exactly why I needed 1Password is to sign in to the browser in the first place. Okay, so we're going to go check this out. So all items. So we're going to go MSN. That's okay. Personal account. And the code is right here. 4 seconds remaining. Hopefully that's enough time. And off we go. Okay, so let's go get ourselves the plugin. Password. And actually, you know what? It may already be loaded in here because my Microsoft account may load in all my extensions. Yep, it did. Okay, so yeah, you can see here, yeah, so it's loading in all my extensions, so that's cool. Okay, so then of these, um, yeah, definitely want this one to appear, and probably want this one and this one. Okay, we haven't grabbed Obsidian yet. Okay, but here, the real reason we're here is to do some benchmarking. So let's do some benchmarking here. So Edge. Uh, yeah, I don't think I'm going to use that one. So we're going to put this on the right. Bueller. Okay, I'm not sure why I dislike that setting. But for some reason, Edge was not responding to my directions to rectangle. So what's going on with rectangle here? Rectangle, there we go. It just wasn't set up there for a second. Okay. So on my website, I blogged briefly about local LLMs. So I tested this on my work laptop. So what I'd like to do is pull these models and ask them to do a similar thing here. So what we're going to do, we're going to pull up the activity monitor. Okay, we're going to put the activity monitor on the lower left. We're going to put the terminal in the upper left. And we're going to say Olama serve, Olama run, qwen 32. Of course, this will take just a second here. Okay, so while that's loading, look at our memory here. So yeah, so base is using just about 25 gigs, just with minimal stuff open here. So I guess that is a sign that the 24 gig Mac Mini that I tried earlier was not not keeping up. I just took that one back and I didn't benchmark it, or keep formal track of how much it would do. But it seemed to be struggling a little bit with the 32B models. The 7B models, it was fine. Um, so let's see here. So this is actually a three-screen setup. I'm trying to figure out what to do with the dock. So I guess what we can do here, though, since I shrunk the dock a little bit, I'm going to tell Rectangle to reallocate this here. Left, top left. Okay. Got some settings here to change. So profiles. So I will set this shell to exit. When the shell close if the shell exited cleanly, which it almost always does. So that's good. Okay, so yeah, so what we're going to do is benchmark these. Actually, I messed this up a little bit. This should be dash dash verbose. You can see we're pulling at about 70 megs a second. On the upper right here, I can see this in this graph, which is kind of helpful. So yeah, and then let's check. I think this machine has half a terabyte of storage. Yeah, so probably need to get a NAS or something set up. I'm gonna do a whole bunch here. Okay, and interestingly, so I think we can actually watch the power consumption of this. Yeah, I don't know if you can get to the dashboard from here. I mean, the energy estimate in here doesn't tell you in watts, I don't think, what we're using. So let me just check on my phone on the Govee app here. Okay, so this is the Mac Studio. And we're only using 40 watts here. Oh, 53. Okay, so 40 to 50 watts it looks like. Yeah, it's jumping back and forth between 40 and 50. Kind of interesting. So yeah, it seems, we'll see what happens when we start running some models here. I'm going to try some 70B models here, 70 billion parameter models. But yeah, you can see it takes a little bit to download the 32 billion models. So actually, as soon as that one loads, we can start pulling the other models as well. Although I don't want to mess too much with I want to make sure we're not messing with any benchmarks that we're running when we do that. Okay, so while we're waiting on that download, there's a couple other things we can do. I've got frankseiler.com/setup. And I really should go through and make these a little more copy pastable. But one of the things that's really nice to set up for yourself is this screener, see, and makes it easy to run, you know, multiple terminals there, especially if you're logging in over SSH, which probably will be quite a bit on this machine. Got the Mac Studio because it's going to stay at home, and then we'll connect over OpenVPN to get to it. And then one thing I haven't set up before is Open Web UI. So may take some experimentation to get this going here. UVX. That's very interesting. So, okay. Yeah, so let's get signed in here. Okay, so that's almost done. So we're going to do brew poll. I think you can brew poll, or not brew poll, Olama poll. Okay, so it only expects one arc. So Olama poll, and then qwen, whoops, Olama poll. Let's see what this other model is. Uh, Get signed in on Google here. Get into the blog so I can edit that blog post. All right, so it's working for local LLM. Okay, here goes nothing. So this is going to be QW. I think QW2 stands for qwen within qwen, but don't quote me on that. This block editor is new to me, so add after. That's not, there's got to be a way to add another row here. Table. I move up. Oh, insert row after. Kidding me? There we go. Okay, so this is M4 max. UWQ32B, and we'll find out how fast it is here in a second. So this is the prompt I gave. So let's see how she does here. That is much faster. I don't know exactly how fast it is. We'll find out in a second, but that is definitely better. Okay, suggesting a different approach than I might take, but I'll consider that. Of course, if we want, we can pull up the GPU history here. That's CPU. I want a GPU. Okay, so we're saturating this has 40 GPU cores, so it appears to be saturating them, which is good. And yeah, we're using, 45 gigs of RAM or so. I mean, some of that's the cache, of course, so, you could probably get away with pushing it harder than that, but you don't want to push it towards swapping if you can help it. Yeah, 18.6. That is pretty good. Now that's eval tokens per second versus how do you want to say that? Prompt evaluate or prompt understanding, prompt evaluation. Okay, so it is nearly 4 times faster, which actually makes sense. So this machine has 16 GPU cores and this machine has 40. So actually it's pretty close to proportional there in some ways. Okay, so we're gonna, that'd be cool if there's a duplicate row. So insert row before. That's actually not what I want. Okay, hit table, insert row after, and do it again. Okay, so we're gonna copy this. Two. Okay, and of course we gotta pull these models real quick. So let's pull this one. Now, I guess in theory, I should probably warm these models up a little bit. So I guess we can run that again here. Um, I mean, I can't say for certain without seeing the math, but it does feel like it's running a little faster, and it's not completely saturating the GPU this time, which is interesting. Now, of course, who knows if there's any interrelationship because we are doing some network traffic and some disk I/O and things. So, but yeah, this I think is going to be very acceptable for my use cases. Yeah, I don't think I've used Flash-RESTX. I've used Flash-OpenAPI 3, I think. Yeah, so what I like about this model is it does a lot of thinking. So that's interesting to see, although whether it's actually, models don't really think in the way that you and I do. So yeah, I mean, I'm not seeing anything that looks problematic or offensive or anything. Like it seems like it's doing a pretty good job here. Okay, let's check our power consumption now that we're kind of maxing this out a little bit here. Okay, I see 130, 115, 125. But yeah, I mean, certainly for a 4x improvement in speed, I didn't really take power consumption into account either with the Mac Mini or with my M1 laptop. Okay, now one thing that's possible here. Well, it looks like we've finished. So I don't know. Not sure if it's slowed down any or not. – 16.84. Okay. I mean, I can just curious. That's what am I doing with other stuff on the machine? So, okay, so while that's running, what we can do with slash models. Yeah, okay. Uh, am thinking. Okay, so yeah, it's got 128K context window. That's another thing we haven't played with yet is the context window on this. Yeah, it'll be very interesting to see what the result on this is. And then we'll run AM thinking. And I have no idea. I mean, obviously, I could test this code and see if it works. Trust but check. And be careful too, because code generated by LLMs can be, how do I want to say it? A little spaghetti. Yeah, so for power, we're at about 130 watts right now, 117. So it seems to bounce around a little bit. Machine is not really warm even. I mean, there's a little bit of warm out the back, but the box itself seems pretty cool to the touch. Room temperature. Okay, groovy. So 17.3. All right, so we got slightly different. That's not surprising that you get different results. We do have another model loaded in this case. Um, so got to do the both. Load that up, and we're going to ask it the same thing. And wow, that's flying. I think we might be in the 30s or 40s on this. This is only a 7B model. Holy moly, 71.23. That's pretty good. I mean, to be fair, that's not quite 3 times faster than the other machine. It seems like it might be roughly proportional with, as I said, with the number of GPU cores, because as I said, this machine has 16 cores, GPU cores, and this machine has 40. So the fact that we're getting, so what is that, 2.5 times as many? We don't have like Python yet, still have Python. Oh, no, no Python either. So we're going to install Python. Actually, that. Okay, so let's get that going there, and then we're going to do Olama again and try this again. Yeah, so I'm wondering if the speed here is just roughly proportional with the number of GPU cores. So 73.2. Wait, start it up again. And this isn't going to be as quality a response as you get from a bigger model, which makes sense. The code may or may not work. So 72.1, pretty good. Yeah, so okay, and then let's try AM thinking here. I think I can get away with, by the way, I'm using Control W to delete words. I think some Docker. Okay, so yeah, this is actually a bit of a problem. So I'm pretty sure this is the model I used. So let's see. Okay, load it up here. Yeah, but you can see the 7B model wasn't really even saturating the GPU in the same way that the 32B model was. Okay, and then let's see here. I'm trying to think. I wonder if what we should do. That was qwen 2.5. The qwen 2.5 comes in a 72B, so we can try that. That's going to take a while to download. So poll. Yeah, it's almost 50 gigs. Pause on that here. Finish loading this guy up here. So we're actually pulling at 68 megs a second, but these averaging rates here take a little bit to become consistent. Well, although I guess we could be, yeah, we might have been using some bandwidth over here too with the Python. Yeah, so 40 over 16, I'm pretty sure it's 2.5. So we'd expect if it's linear with the number of cores that it runs 2.5 times faster, which actually I think we're doing a little better than that. And the reason we may be doing a little better than that is because it's an M4 versus an M1. Not really sure. Also, there may be some memory pressure on my okay, customization to make is in the Python has some annoying defaults. So let's see if we can fix those while our download's happening here. Python. Yeah, here we go. Yeah, I really need to redo this in Markdown or try the block editor and see if there's a better way to do this. So now if I go to IPython, Control D works. Okay, great. Oh, well, this is a job there. And I'm just going to give this a little kick here and see if we can get a little more reliable. Oops. Speed estimate of how long that's going to take. Okay, so this model here is another. I think I'm thinking V1 is 32B. Oh, I thought Olama had a. Well, I think it's LMS, which is a LM Studio. Oops, LS. There was a way to get a. Oh, I guess there's no V for both. Okay, so that's kind of boring. Okay, but we're getting loaded up here. I'm trying to think of what other system things I need in order to test this. I mean, before long, you start playing with start adjusting the environment variables for Olama so it can handle context lengths. I think it defaults to 2K. So we've got so this large qwen model that we're going to pull is 32K, and then I want to say I'm thinking it's 128 key. Okay. Okay, yeah, it's 128K. It would be nice. Olama might have the ability to actually. I think you can actually set that in a custom model file, which is not something I've played with yet. So looking forward to trying that. And I cancel that. being. Okay, less than 2 minutes, hopefully here. And I guess there are a few other things I can install. Like I can go ahead and grab brew, install YT-DLP and FFmpeg. Okay, so I'm going to predict that this model, I don't really have any experience with models quite this big. I'm going to predict this might run at, I don't know, 3 to 5 tokens a second maybe. So it's going to be slower. It'll be interesting to see if it produces any notably better. Um, well, I'm sorry. Okay, so this is 32B. So this should be roughly similar to QWQ in terms of it's the same size-ish, same order of magnitude. When we go to the 70B model, the qwen 2.5 70B model, it'll be curious to see. So I'm pre I'm going to guess that this AM Thinking V1 is going to run at roughly the same speed. In fact, maybe I should even kind of drag these rows around a little bit in the chart here. So I'm going to predict, we're going to get about, you know, the same sort of order of magnitude. So maybe 20 tokens a second. Okay, so hopefully we're getting close here. Usually takes a second to process the model. Okay, I think the download seems pretty good there. Okay, got a couple little extra layers here. Yeah, so it's going to process that 20 gig file. Okay, and then we also have some CPU going on here with installing here, so I want to wait for that to finish before, so we give this a fair shake. And I'm having a recurring issue with my monitor where occasionally it just goes blank, but I trust that's not affecting the recording experience here, so hopefully that works. But if I pause for a second, it's probably because the screen went blank while I was trying to look for something. This 8K monitor from well, it's a TV really from Samsung, is a little goofy. Um, Gets particularly goofy when you feed it within 8K. So actually, that's interesting. Let's pull up the system information. So if we look at displays, graphics display. Yeah, so that's interesting. So it's running it at 4K, even though, well, I wonder what our recording is going to be at. But actually, this display, I'll show you, this display, to be honest, goes to, it goes to 8K. So, yeah, I don't know how that's going to affect the quality of experience here. Okay, so it looks like that installation's done. So now we're going to do the same thing here. So we're predicting about 20 tokens a second, if I had to guess. Okay, so it's interesting. So this model, even though it's a different model, also choose Flask-REST X, which again I haven't used. And of course, these things are always going to be sensitive to what inputs you can give it. One of the models I tried on my work laptop suggested Flask-OpenAPI 3, which is one I'm familiar with and have used before. Haven't used this particular thing. So, and again, this is a thinking model like QWQ, so you would expect it to do a little thinking here. And again, we're pretty close to saturating those GPUs. So, and I haven't played with, I'm not a big hardware guy. I haven't built a PC in 20 years, maybe even longer. I think I remember building one in 2002. I think I built one in 2004, maybe. And I'll do the occasional hardware upgrade, but honestly, it's cheaper and easier to buy from an integrator. I don't have time to mess around with Mickey Mouse issues. And so for me, I think this is a good solution. It's not particularly cheap. There might be ways to run these models at similar speeds for cheaper. But when you get into dealing with PCs, you're dealing with all these different potential specifications. You're dealing with a kind of an immature ecosystem. Or trying to go to like an industrial solution with like an H100 card or something like that is very cost prohibitive. Trying to run this on Azure is cost prohibitive. If I ran a VM on Azure for about 45 days, it would pay for this hardware. So, it's kind of nice to own the hardware. Of course, I don't know how Azure would actually perform because I never actually got to the point of attempting any of the experiments on Azure because they wouldn't let me spin up the VM I needed. So, for me, I think this is a pretty plausible solution. Really, what I'm going for is my own personalization and being able to put very personal information in here without relying on ChatGPT or another vendor. Uh, Although I might consider some of these things, once I develop the context and the memory that I want, if it's plausible to run those, say, on Azure against the OpenAI models, I might consider doing so with the API. Okay, I mean, I wouldn't say this is booking, but it's certainly doing plausible things here. And note, these are not coding models in scare quotes, right? These are just fairly straightforward generic models, general purpose, not specific for coding. So if they can produce working code, that's a nice touch. Yeah, so why am I doing this? I'm doing this because my wife actually really enjoys it when I sort of live stream my, thoughts when I'm debugging or thinking about problems. So I thought I would go ahead and do that and share it with the internet here, and maybe y'all will find some benefit in this. Just me setting up a new to me, well, brand new machine, uh, getting the basic tools that I expect and need on board. Olama is not the only way to run these models for sure. I'm still learning about sort of the evaluation ecosystem here. Um, my, my thought is that, or conception of the way this works is that you have like LM Studio and you have Olama, and I think basically, they're like Java runtimes. They can both run similar types of models. What I'm not clear on is, file formats, and I know that this uses effectively sort of the Docker layered storage and transmission and sharing mechanism. So it's similar to, Olama.com, I guess, is similar to DockerHub.com in that sense. And you can also set up your own repositories and everything. Um, but there's a lot I have to learn about this ecosystem. So I don't claim to be an expert. I do claim to be a skeptic. I think there are a lot of charlatans, claiming that, they have this advanced knowledge of how to do magical things. And the fact of the matter is, these technologies are not magic. It's actually a disservice to our trade to treat them as if they are magic. They are useful in some circumstances and not in others. So that's true of any tool. Potentially a very powerful tool, especially when it comes to text. Um, but I don't think. I think what happens is this is represents a level up in our technology in the same way the automobile did, or access to steel did, or even access to things like writing utensils, right? It chops off sort of the least interesting layer of work and adds another layer of interesting work on top. So my thing is, at my age, I want to make sure I keep up with these things because they're very interesting, and there's a lot to learn. And learning about the upsides and the downsides is what we call that's education, right? That's the definition of education. So if I can help someone else develop a healthy respect and a healthy skepticism, then that's why I'm here. Okay, so this is giving us a pretty detailed here. It kind of built a whole demonstration class for me, which is nice. Yeah, I'm guessing we're going to be in the, you know, 20s-ish, low 20s. Okay, 15.6. Okay, that's not way off. It's a little slower than I would have expected, given that the other machine, we went from the ratio here 18.6 over 5, basically, right? So I would have expected this to be a little faster than that. But, that was our first run. So let's see what we get if we crank this up a little bit. 15.6. I'm just going to kill this and start it up again here. What I don't know is if I hit tab here, will that give me a new? No, it will not give me a new row. Okay, because there is one more model I want to try on this that I don't think I can plausibly try on the other machine I have access to. Okay, so we're going to do this. We're going to do qwen 2.5, 72B, I think is what it was. 72B. And let's see here. This downloads. Yeah, so we're already down, 100 gigs or something on storage. So, because I think it's a 512 disk. Intention is to do an aftermarket upgrade on the disk on this, or potentially just start putting this stuff in a NAS. Okay, so what I don't know is if this pull is having any impact on the. Just want to make sure if we're meant to saturate the GPU that we can. Yeah, it did. It's using a little more GPU now, so maybe the I/O kind of messes with the LLM a little bit. I mean, obviously, if you were doing this for real, you would kill the browser, or you would do this on a headless machine or something like that. Just do it over SSH and minimize the impact of other things on this. Okay, I mean, some other little touches here, date and time. So I prefer the 24-hour. Okay. Um, yeah. So I think that's pretty good here. Let's check and make sure. We just updated it. It just came out of the box and it wanted to update, so we just did that. So I think we're good. Yep, looks like it. What our power consumption is like here. Yeah, so we're at about 130, 115, 127. But yeah, it's a couple of 60-watt light bulbs, give or take. Um, I definitely feel warm air coming out of the back of the machine. Top is, just slightly warm to the touch. Otherwise, it's pretty good here. Yeah, so next steps would be, I mean, pretty much what I'd like to do right now. All of these questions and answers are, well, I guess the questions are being saved. There's a history for the prompt. So I'm just hitting the up arrow and saying run the prompt again. So it's exactly the same prompt for each model. The answers, as far as I know, are throwaway. So one thing that would be nice is to configure this to store them in, Postgres or SQLite or something like that, just so that you have some reference back into, because, I wouldn't mind testing this code. We just, for the purposes here, we're just trying to determine, does it make sense to keep this machine? So far, I'm leaning toward yes. Uh, as I said, the 24 gig Mac Mini. So this machine, to give you an idea, is roughly 4 times the cost of four. It's roughly four Mac Minis worth, right? But if it can run bigger models and it can run them faster, then that's the thing. On memory, I mean, I think 128 gigs is certainly respectable for running a 70 billion parameter model. Um, I wouldn't mind eventually looking at getting something even bigger, more memory. However, I want to wait probably until the M5 comes out, and hopefully then they'll have options. Right now, if you want more memory than what this machine has, you have to go with an M3. I don't know if that makes a heck of a lot of difference because, the M1 seems to be keeping in there really pretty well, all things considered. Yeah, because the M1 did a demo at, almost 6 tokens per second, and we're a little less or a little more than 3 times faster here. So not a heck. Well, actually, I guess that's if it's proportional with the number of GPU cores. Let's see here. 15.6 divided by 5.73, 2.7. So actually, proportionally, we are faster than just the number of cores. So yeah, so I guess that's not too bad. And I'm curious about, we got an even better ratio on this other model, on the QWQ32B. Okay, so let's average these. So let's say it's 18.6 plus 16.8 plus 17.3 divided by 3 divided by 4.97. 3.5 times faster, and we only have 2.4 times as many GPU cores. So there's definitely something there. What's very plausible is uh, well, it could be memory. I mean, I wish I'd taken these statistics for the Mac Mini. Um, one possibility is with this 32 billion parameter model, which I think is about 20 gigs. I think it's 19 or 20 gigs. One thing that's possible is we're starting to saturate memory, and so this machine might be having to swap memory. So the memory bandwidth and other things come into issue, potentially is why that this number actually seems a little low compared to what I might expect. So. Okay, so I mean, although this is tolerable, it's not particularly fast for this use case here. So it's just now getting to the point where it's answering the question, showing something that the user would think about. So if you went to ChatGPT and asked a question like this, you would expect a response within a couple of seconds, maybe 10 seconds at the most. Um, I guess it depends on what model you're running, but if you're running like O3 or something like that, you have a limited quota for that, and they seem to have the horsepower to run it. So it's interesting to see. It's definitely um, some clock time here. And I haven't played with the running, like, for example, even the batch API might be an option for some of the work that I do in Azure. And Azure actually has pretty compelling prices for a lot of these. So Azure Run Open API or OpenAI cost. Um, so I mean, I'm really liking O3. So O3 is $10 in and $40 out per million tokens. So I guess we can see how many tokens we return here. We can do a quick calculation, how much that would cost. I don't honestly know the difference between input and cached input. I'm guessing they're just calling this the context, maybe. So, but there are much cheaper models. Here, this model is, a tenth the cost, give or take. And, GPT 4.1 Nano is quite a bit cheaper. So, okay. So we got back 7321 tokens. Okay. So 7321 divided by 1 million. It's $40 per 1 million times $40 per million. So that would have cost about 30 cents to run. So that's not too bad. Well, plus the input token. Um, so input tokens were only how many input tokens? 96. So it's really pretty de minimis. So plus 96 divided by a million. By the way, in Python you can write a million as 26. This is times 10 to the sixth. You can also, by the way, write numbers with underscores in them, which is useful sometimes. So divided by or times $10. Okay, so yeah, it doesn't really make any difference. So it's 30 cents, call it, to make that query against O3. And O3 would give you a similar response, I think. Okay, so now let's see if we can try the big boy here. Well, actually, we're going to run gross. Now, one thing I haven't done here is eject the model. Eventually, it'll garbage collect models here, but we're not running out of memory here. We've still got pretty good amount available, so I'm not too worried. Yeah, so I got about 8 minutes to go there. I mean, I suppose what I could do if I wanted to eject those models is just restart here. My earbuds out for just a second to sneeze, so hopefully that doesn't render too bad on the audio there. I don't intend to do any editing on this. This is just kind of a live stream. Oh, it started all over again. Whoops. Okay, so we got about 11 minutes to kill here. Okay, so what else do I want to do with this machine? I'm just trying to think if there's anything I need to set up. I mean, I could go grab LM Studio, I guess. Um, I've got a whole playlist of LLM related. I'm surprised it didn't sign me into YouTube here. There we go. Okay. So, where did I put the playlist on here? Did I open this? There we go. Playlist. Yeah, so I've got a whole LLM playlist, which I suppose I could make public. Um, I've got, if you're wondering why the video isn't playing right away, it's because I installed this handy disable HTML5 autoplay because I don't like it when videos play without me. I don't like my computer to make sound unless I ask for it. So I've got 91 videos stored up. None of these are mine, of course, they're from other people. Um, in particular, what I want to study is teaching models things, right? So customization to my own needs, personality, that kind of thing. So that is, there's a tool called Letta, which is the new name of something called MemGPT, building an AI that remembers you, building multi-agent systems. So what it'd be really neat is to be able to share knowledge between me and my wife, and also have our agents reach out to other systems. So, for example, I don't have Home Assistant running in the house yet. I'd love to get Home Assistant running in the house and be able to do things like control lights and things. Um, and then, of course, there are things that I need to figure out, like can I command, can I use my phone, for example, to boss around, to be on Open VPN to the house, and then boss around the LLM that's running on this new machine. So we'll have some things to figure out along those lines. But yeah, there's a lot to learn for sure. I guess one channel that I really recommend, and it seems pretty, some of the channels I've seen just have they're charlatans. They really don't understand the technology. They're asking it things that just don't inherently have any veracity to them, right? So I think the channel that I really like is this Matt Williams. Of course, it's not gonna, is it gonna link me? There we go. So yeah, Matt Williams. He seems like he's really got a good head on his shoulders and really understands sort of the fundamentals of how these systems work. So shout out to Matt, technoevangelist.com apparently, and you know, yeah, he's a founding maintainer of Olama. I think he probably has some understanding of how the tech actually works, right? And he hasn't proposed anything that I thought was completely nuts. I saw somebody say, hey, I went to ChatGPT and I asked it, what prompts do people ask you about? Well, so the model doesn't know that, right? Unless OpenAI is feeding it back to the model, which they probably wouldn't for a couple of reasons. So one is that's very proprietary, and you want to monitor that for yourself and understand how your customers are using your product. You probably don't want to expose that back out to other people, right? So ChatGPT is just going to make something up that pleases you, right? In fact, as Terry Tao said, I wish I could find this. So Terry Tao is a very famous and very elite mathematician, and he said, we should be especially skeptical given that these models are designed to produce things that look plausible, right? They have no grounding in reality or truth. So are they useful for punching up an email? I mean, yeah. Just be careful. It's a little like auto-tune. You can kind of hear it. If you listen close enough, you kind of, oh yeah, that person doesn't actually sing very well. They've been auto-corrected very heavily. Right? Auto-tune used sparingly and tastefully is a different experience. Funny story today. I guess I can relate funny stories because we got 8.5 minutes to go here on this download. Uh, I, Jason Fried is the founder of 37 Signals and Basecamp and all that good stuff. He's written a couple of good books. Good guy. Seems like a really down-to-earth, solid guy who treats his people well. And the products are pretty good. And I believe he's the inventor of Ruby on Rails for that project. Well, I know they use Ruby on Rails. I'm not sure if he wrote it or someone else did. Anyway, point is, Jason Fried posted something about, he can kind of tell that a letter or a cover letter or something like that is written by ChatGPT because he said it's the color brown, which I find interesting, right? And his point is brown is kind of uh, Chat GPT is kind of all the colors mixed together is brown, right? So I thought that was very interesting, and I responded, "Hey, actually, to me, uh, it's in parallel with." Let me see if I can find. I guess it's a notification. Yeah. So here's the conversation, right? So Jason Fried says, when you review hundreds of cover letters, you can easily spot the ones written by AI. The best way I can explain it is that AI writes in brown. Combine all the colors and you get brown. Combine all the writing styles and you get brown writing. It's easy to spot that color, right? And I said, very interesting. I like an LLM to auto tune. Everything comes out a little too perfect and bright. And he wrote back, auto tune is an interesting parallel. So I feel like I got a shout out from the man himself. So that's neat. Um, that feels like a feather in my cap. So cool. All right. So that's enough messing around with stories, I guess. So let's just see if we can get this model downloaded here. Curious how it goes. And I'm curious how this video turns out. So I think I've got all the tools I need to upload it. I've got FFmpeg, so it'll be my first protocol. I don't actually know if YouTube will let me. I don't know if YouTube will let me upload an MOV file or not. Guess we'll find out here in a minute. And I don't have like a timer or anything on here, so I have no idea how long this video is or how long it's going to be. Um, yeah, interestingly, QuickTime, you do the recording in QuickTime Player, and it doesn't have preferences. So what would be cool is if it had the ability to, if it had the ability, oh, I guess that's part of the reason we're eating disk too, is because I'm streaming potentially in 4K here. It would be cool if you had the ability to tell QuickTime, hey, please export as HEVC or H.264, H.264, H.265, instead of kind of relying on whatever. But yeah, I mean, I think I'm pretty good. I mean, I think my mental idea was I wanted something that would do sort of 20 tokens a second on the models that I want to use, and the models I want to use are, I think, um, QWQ and the AM thinking model. So maybe it's a little slower than I might like. Um, I don't know that I want to spend the money on an M3 Max. I mean, I guess we can price that real quick. I mean, obviously these are just gorgeous machines. They work really well. The frustration can be on the software side, but I think that's inevitable with this evolving. We just have an evolving situation here where this software all good software takes 10 years, so it's going to take a while until this ecosystem fully matures. But let's just see what we got here. So M3, yeah, for the 60 core GPU. So allegedly that would be 50% faster than what I got here. Um, or the 80 core GPU. Wow. Okay. Um, so 4,000 versus 5,500. Okay. So that's more than double what I paid for this machine. Hmm. However, it's also double the number of cores. And these models seem like they are okay. And the least storage you can get is a terabyte. Okay, that's fair. Hmm. Yeah, I think that's a that's a maybe someday if I have some success with this. I think I'm going to live with that, 16-ish tokens per second with that model. And who knows? Well, I guess, yeah. Well, I guess I never filled this back in. So 15.4. And then I think the big boy here, this big model, is probably going to get, if I had to guess, maybe 3 to 5 tokens a second, which is slow, but if you let it run for a while, Yeah, I guess this is just kind of today is day one, so I've got 2 weeks potentially to return this machine if it for some reason it doesn't live up. I was kind of hoping it would. So we'll see here. I didn't really have the hardware play with the memory stuff. I suppose in theory you could do it with a Pi and then call Azure, and use the OpenAI models or something like that. Use some hosted model. Okay, so I think I'm going to finish up this. I think I'm going to do one test run here and then call out of here. I think I've been going about an hour. Not real sure. I guess I can check here. So I think I set this. Oh, well, movies. Huh, interesting. So I guess QuickTime hasn't written any video to a file yet. So I guess we'll see how that goes. Okay, we're in the home stretch of this download. Yeah, I mean, maybe this isn't the most exciting video ever, but I just wanted to put some thoughts on paper. Maybe somebody enjoys it. Maybe it's like, oh, Bob Ross, the painter, where people would put on his videos just so they could fall asleep. Maybe that's my special sauce here. The guy doing computer stuff and just kind of rambling on and on. Okay, this may take a second here. Okay, so we're going to be up and running here. Let's see how fast this goes or how slow it goes. Actually, that is surprisingly quick. I'm impressed with that. Okay, I think we're probably at least 10 tokens per second here. Yeah, and this also used Flask REST X. So Flask REST X, I guess, was the popular thing at least when these models were trained, and all three of them picked the same model. So very interesting. Okay, yeah, I mean, as expected, it's using about 70 gigs of RAM. Of course, that's total, and then you got 55 gigs of cached files. So, I mean, I guess if you wanted to be pure about this, like I said, you'd boot the machine and just sign in over SSH to kind of minimize the baggage and your loaded files, and reboot the machine after each model, just to make sure that you've got it cleared, got memory cleared out. But I'm actually pleasantly surprised at how quick that's running. It would be interesting to compare the results between the 7B and the 72 billion parameter model. And this is not I'm using air quotes. This is not a thinking model, right? This is just a model that kind of gives you the answer right away. So, um, but yeah, I don't see, there's nothing here that looks like it's just won't work. Sometimes you'll see LLMs do things and you say, oh, that will never work. Sorry. And it looks like it's producing output in Markdown, which is kind of nice. Yeah, 8.75 a second. I'm impressed. I predicted 3 to 5, so for it to go like almost 3 times as fast, or twice as fast. So another thing that would be interesting, there's a concept of temperature. It'd be interesting to study sort of if you do different runs, what's the divergence between them. So in this case, kind of just warming up the model here with that first run. Although it seems like it pretty well, these runs are not radically different. 71.2 versus 73.2 is not, it's not going to make a difference for this length of output. So, and I remember Letty Harrison, my professor in college, computer architecture, talking about if you're saturating any part of a machine, that system is not going to go any faster. So in this case, we are saturating the GPU, I'd say. So that's good to know. And as you said, latency is another thing that people don't think about as much as they could. And you think about like all the virus scanners and stuff, and how your computer might be slower today than it was 25 years ago, just because we run a lot more stuff and we don't think about latency. And that's sort of an issue for the profession. Okay, so we did 8.84 here, so a little bit faster. And just for giggles, I'm going to run it one more time, and then I'm going to go grab some dinner, I think. Yeah, it's interesting. It seemed to open about the same way. Certainly, below is an example. Okay, we're just going to check our power consumption here. I don't know if more memory means more power. Maybe a little bit more. Okay, so we're running, I saw it jump up to like 139 watts, 135, 128. Yeah, it's a beautiful machine. I mean, everything's set up quickly, as you saw. Seems to do all the things I expected, so that's great. Oh, that's interesting. It made a goof here. So if name 00, so that should be, this is called a dunder in Python, so it should be two double underscores named and then two more double underscores. So that's a bug. But we're looking at evaluation here, not necessarily whether the model is well suited. I'm a little surprised. I don't think I've seen that particular kind of blunder before. All right, what's our speed here? Yeah, it's a nice little touch that gives you the instructions. I wasn't really paying attention as to whether it gave us how to install the requirements, which I always appreciate. 8.71. So yeah, we'll take that. That's not bad at all. All right, guys, I'm gonna go get some dinner, and thanks very much for hanging out.